Insert a truss again using either the lock to base method or snap against the bearing envelope, whichever works best for this situation. Next, add top and bottom cuts. As you can see, cuts can also be applied directly in layout mode. Once done, recalculate. Now check the 3D view. That looks good. Just fill in the missing areas here and the profiles looks correct. There's one more valley truss run needed here, and then we'll be ready to move forward. Just like before, repeat the same steps in this area. Let's do one final check on the valleys. Looks like everything is correct. We can now move on to adding corner sets. To do this, right-click and select Add Truss. Before creating the corner set, add a hip girder truss first. Adjust the span to the correct length. Then, right-click on the hip girder and select Create Corner Sets. Next, select the two planes that define the corner set. Once selected, the corner set is generated. To complete the trusses, fill in these missing areas. Make the necessary span adjustment on this truss, and now the corner sets are successfully added. Now check the 3D view to ensure everything the profiles are correct. Examining the profiles, everything appears to be right. However, the hip girder here might overlap or cannot properly bear on this beam. We could resolve this by deleting the girder and extend these trusses so they bear directly on the wall. The result should look something like this. Now, follow the same process for this side. Since there's already a girder here, simply right-click on it and select Add Corner Sets. Select the two intersecting planes to generate the corner set. Fill in any remaining areas, then place a truss girder here. Ensure that both trusses share the same left and right points if you are adjusting the ends using a bounding work line. To align them, simply flip the truss envelope to align their endpoints. Now, both trusses are aligned properly. Adjust the span of these trusses as needed. Remove any existing work lines to prevent unintended extensions, add a bounding work line, and recalculate. Now, let's complete the remaining trusses and make any necessary adjustments to finalize our layout. Since the overhangs can be adjusted during the design phase, we'll leave them as they are for now. As for these gable trusses, we'll refine their profiles once the rest of the trusses are designed. This approach provides greater flexibility in managing various levels of layout complexity. Doing one final check. Everything appears to be in place. If your project requires piggyback trusses, here's how to add them. Select the trusses that need a piggyback section. On the right sidebar, scroll down to the Cap Set section. Under Cap Level 1, set the cap height to your preferred value. Since this height is referenced from the zero elevation, you'll need to add the top height of the wall where the truss envelope bears, plus the desired overall height for the base truss. If an unusual truss envelope appears, simply adjust Cap Level 2 to a higher elevation to correct it. Now that everything is set up properly, we can proceed with designing all trusses. Remember this error for later, as we'll address it in the next steps. For now, switch to the 3D view to check how the designs look. To view the truss designs, click Designs. Here, the trusses have automatically generated webbing. These configurations can be adjusted in design mode, so be sure to watch the tutorial on how to use Paragon's design tools. The valley trusses, cap sets, corner sets, gables, and sloped bottom chords are now visible. Now, we'll fix the profiles of these two gable trusses. To do this, duplicate an existing truss design that matches the problem truss and link the component copy to it. Next, ensure that the endpoints of the problem truss and the reference truss match. If they don't, adjust them as done earlier. Next, unlink the design of the problem truss. Looking good? Verify that the endpoints are now matching. Let's unlink this one as well. Open the reference truss that will be used to copy. View the component design and make a copy. Take note of the component name for later use. Now, link this copied design to the problem truss. Click Choose Existing Design and select the copied component. Switching to 3D, the design has been correctly applied, but the elevation is incorrect. To fix this, add a bottom cut on the truss envelope, cutting against the higher flat ceiling plane. Unlink the truss again. Add a bottom cut. Click on this plane. and then relink the design. Now the profile looks correct. Apply the same fix to the other gable truss. If the webbing differs, you can create another copy of the design and link it accordingly. For now, we'll simply link the same truss since modifying component designs in design mode is discussed on other videos, which you can find in our channel and documentation page. Now, I will briefly go over how to fix overhangs in design mode. Open the component design, and since this is the left end, adjust the left overhang. Click this button and select Adjust Overhang. Checking the 3D view, the overhang is now correctly applied. Let's continue reviewing other areas. Remember the error noted earlier? This is where it occurred. The truss extended beyond the roof plane. Fix it using the same method discussed earlier. Looking good? Let's continue fixing other trusses. Everything is now looking good. We'll do one final check and make any necessary adjustments. If anything was missed, simply follow the steps discussed earlier to ensure everything is correctly adjusted. Now that everything is good, we can proceed with the tutorial on creating floor trusses in layout. Note that we replaced the structural plan's specified material type only for demonstration purposes in creating floor trusses. Now, input the wall dimensions according to the plan, then insert reference lines to mark the boundaries of stair openings where the girder will be placed. We'll use a bounding work line for the horizontal girder that will be added later. Everything looks good so far. Let's proceed with adding floor trusses. The process of inputting floor trusses is similar to roof trusses. However, floor trusses require a feature pattern container to be added in the layout. To create one, right-click and select Feature Pattern Container. Next, set the bottom height, which should be the top height of the wall where the envelopes will rest. Then define the top height by adding the required floor depth according to your plan. Once that's set, define the boundaries of the container by selecting the necessary edges. And the container will look something like this. Now that the container is in place, we can start adding floor trusses. To add a truss envelope, right-click on the container and select Add Truss Envelope. Alternatively, if the container is turned off, you can right-click on the layout, select Truss Envelope, and then change the component type to Floor Truss. We'll first insert the girder here, then proceed with adding the rest of the envelopes. Notice that some trusses are overlapping. Before designing them, we need to adjust the bearing size of the shorter span truss to 3 inches. This ensures the software automatically set the endpoint of the shorter span truss to use top chord bearing on the longer truss. Use a bounding work line, then recalculate the truss to apply the adjustment. That looks good. Let's continue adding truss envelopes on missing areas. To view the profile of the floor truss envelopes, enable the Solid option here. This will instantly update the display, allowing you to see the profiles clearly. After filling in the missing areas, we can move on to designing the trusses. Now you'll see that some girder trusses haven't been generated. This happens because the trusses bearing on them haven't been analyzed yet. To fix this, we need to analyze them first. Before that, let's combine this truss with its adjacent truss. Now analyze each truss that requires it. We'll also combine this truss with the one next to it. Now that all the girder trusses bearing on this girder have been analyzed, we can proceed with generating the truss girder. Just make sure to analyze any remaining non-girder trusses that are bearing on this girder first, as the software will not allow you to analyze the girder until all bearing trusses have been analyzed. It looks like the girder has successfully generated. Let's do one final check in 3D view. Going back to the overlapping trusses, they now appear correctly bearing on each other. And that wraps up this tutorial on creating a complex layout. I hope you found this video helpful. Be sure to check out our other tutorial videos and visit our documentation page for additional guidance.